Hey all, welcome back to my channel. Welcome back to the SV sessions. In today's class, we are going to discuss about data types in SV. In the previous session, I have already discussed about the SV test bench architecture. Okay, so many of you are asking me like how will be we will be writing a code in SV. Okay, so for that case, in the next class, I'll be showing you how you will be writing the code in SV test bench. Okay, SV test bench. Test bench, SV test bench is nothing but we'll be executing the same. We can execute an EDA playground also. Okay, I'll just be showing some example how you will be writing the test bench in SV. Okay, so in today's class we are discussing about data types. So we have already discussed this data types in Verilog also. But the important thing in SV is SV is having many advanced data types compared to that of Verilog. Okay, so in Verilog, what are the data types you have learned? Like rich, wire, integer, real, time. Okay, so these are some basic data types you have learned in Verilog. So in system Verilog, what is happening is along with these data types, you are also having many more data types for usage. Okay, so in this again, this data type is categorized into two types, like predefined data types and user defined data types. So predefined data types means, I think you already know it from the name itself. They are already predefined in the system Verilog library. You can just call it and use it. Okay, and then coming to user defined data type. So user defined means the user itself will be defining some kind of data types based on the usage. Okay, for example of this user defined data types are like enum, okay, like classes. Okay, these are some of the user defined data types you will be learning in system Verilog. Clear? And also one more important thing in data types in SV is, so in Verilog if you see, okay, when you are learning about the data types, I have already told you all Verilog data types are of four state data types. Like what are the four states? You will be having 0, 1, X and Z. Okay, so in Verilog you are having all the data types that you are learning in Verilog. They are all four state data types. Okay, but in SV, along with this four state, one more state called two state is also introduced. Okay, so the two state means it will be having only two values, like it can be either 0 or 1. Okay, it can't give you values like X and Z in just you see in a Verilog. Okay, in some data types you don't be seeing this X and Z values in system Verilog. So this is one of the major difference between Verilog data types and system Verilog data types. Okay, hope you got the point. So when anyone asks you what is the difference between Verilog data types and system Verilog data types means, in Verilog you are having four state data types, but in system Verilog along with this four state data types, two state data types is also introduced, where the data type can hold only two values like 0 and 1. Okay, so that is one difference. And the second difference is, in system Verilog you can also use the user defined data types. Okay, along with the predefined there is also user defined data types in system Verilog. Okay, so now let us see what are the kinds of data types that you will be seeing in the system Verilog. Okay, you already know about nets. Okay, in nets you are having all these data types. Okay, and then coming to variables. Okay, variables means where. Okay, like just like register, right? So nets and rich, and then integer data type and real data type. Actually if you see in Verilog you are having only these four kinds, is it or not? Also of course in Verilog also you will be having all these sub data types like war, w or wn, okay, try or try and all these things. But in system Verilog, what is the thing that was introduced is, in Verilog there is only integer data type and real data type. But again in system Verilog, this integer data type is again categorized into two types. Okay, this integer is having again two state and four state, where the two state data types are like bit, byte, shortint. Okay, you are also having like int and long int also along with this. Okay, and then in four state you will be having register, logic, and time. Okay, and then in real you will be having real, short real, real time, right? So these are all kinds of data types that you are going to learn in system verilog. Clear? Right? So now let us see what are the newly introduced ones in system verilog as for now. Along with this, you are also having some other data types like enums, okay, and classes. Like, yeah, we are going to see all this in the upcoming sessions. But as for now, let us see some basically introduced data types in system verilog. Logic, bit, byte, shortint, int, longint. Okay, along with this, you are also having string data type also. Okay, so when it comes to bit means from the name itself you could say it means single bit. It can hold only one bit data. Okay, and it of two state variable. Right, so from the two state variable you can understand that it could hold 0 and x. It doesn't have x and z values. Clear? So byte, when it comes to byte is also two state variable and it can hold 8 bits. Clear? So bit means 1 bit, byte means 8 bits. So that means when you are giving byte, it literally means 7 down to 0 bit. Okay, that means okay, bit 7 down to 0 x is equal to byte x. Okay, clear? Yes, so this is the meaning of the byte. And then shortint, int, and longint. Actually, int is again subdivided into shortint and longint. We can say that. So basically, int is of similar to integer data type. Okay, int is very similar to integer data type. Both integer data type and int data type can hold same integer values, but the difference is that this integer is of four state variable but int is of two state variable. Okay, if someone asks you what is the difference between integer and int, here the difference lies in the states. Like int is of two state variable, that is why it can hold 0 and 1 values, but integer is of four state variable, that is why it can hold 0, 1, x and z values. Okay, that is the main difference. So by default int can hold 32-bit values. Okay, so half of that is shortened, like 16 bits shortened, and double of that is long int. You can just remember it like that. Okay, that means long int can hold 64 bits, shortened can hold 16 bits, int can hold 32 bits. Okay, but all the int family is of two state. Clear? So in order to make you remember very easily, because this is the most frequently asked interview questions, like in order to know how you're strong in your basics, so these are the basic interview questions you will be asked when you attend any interview as a fresher. Okay, so firstly, bit is of two state and it can hold only one bit. And also you will be asked whether it is signed or unsigned. I think you already know about what is signed and unsigned. Okay, unsigned means it can hold only positive values. For signed means it can hold both positive as well as negative values also. So this bit is of unsigned data type. Okay, and then if you see next is byte. So byte is of two state again. Okay, it can hold, what is the size? It can hold 8 bits. And also one more thing is byte is signed data type. That means byte can hold both positive and negative values. Okay, and then coming to int family, we can call this as int family. If you see, all the int families of two state data type. Okay, int can hold 32 bits, half of it is shortened, double of it is longent. Okay, entire int family is of signed bits. Clear? Yes. Then comes the actual frequently used data types like logic, okay, register data type, integer. You have seen all this in Verilog also. Similarly, this here, whatever you are seeing like register, integer, time, okay, all these things, these are 4-state values. Okay, so 4-state values, and reg is user defined. Okay, that means the size is, you will be defining it how much the size is. And as for sign, like logic and reg can hold unsigned values. That means it can hold only positive values. For integer, just like int, for integer also it can hold both positive and negative values. Okay, for time it can hold only positive values. Clear? So all these are 4-state data types, right? And then comes real. Real means the floating values, nothing but some point values. So all these are again, it is of 2-state data type. Okay, clear? So this is about the data types, like what are the size, or what is the default size, and what is the default state of the data types, all these things. Okay, you can just um, uh, click on this screenshot, take the screenshot of this particular thing, and whenever you are attending some interviews and all, you can just take a glance so that it will be easy to remember for you. Clear? So this is the thing. And also I'm not going to explain about signed and unsigned data types because I have already done that in system Verilog itself. So I don't want to waste further time on doing that. Okay, if you don't know like what is difference between signed and unsigned data types, you can see in my Verilog classes where I have explained about data types. Okay, I have created a separate list for both Verilog and system Verilog. You can go check it out there, right? And today we are going to discuss about what are new in system Verilog. Okay, so one of the introduced topic in Verilog is, sorry, system Verilog is logic. Okay, so what is this logic? Basically, the reason for introducing this logic is a replacement for both reg and wire. We can say that. That means why this was introduced in system Verilog. Because in Verilog, while we are using data types also, there are some limitations. So what are those limitations? If you go back to like Verilog, in continuous assignments, that means in data flow modeling, if you see, okay, during when we are writing a code in data flow modeling, right, like RHS equal to LHS, okay, sorry, LHS equal to like RHS. So while we are writing the code, we have discussed that in continuous assignment the LHS can never be reg. Is it or not? Yes, because it is continuously driven. The reason, and that also we have discussed it there. So this is the limitation while we are using this data flow modeling. Is it or not? And then in behavioral modeling, always an initial can use reg data type. Okay, so because of this certain limitations in data flow modeling, by for using this reg and wire in Verilog, so because of this, in order to avoid all these limitations, we have introduced a common data type in system Verilog, which is logic. That means instead of writing reg or wire, if you don't know where to use that, why? Because wire can only drive the values, but reg can hold the values. But hence, when you are designing a complex circuits, okay, while doing connections, you may at some point of time use that as wire, and at some point of time there may be use that it should be converted into reg. So now what happens if there may be clashes, like you have mentioned it as wire and now you are using it as reg, means there may be clashes during simulation. So in order to avoid this, what we are doing, we are using a safe data type, which is logic data type. Okay, so if we are using logic, means it can be worked as both wire and as well as reg. Clear? So that is about logic data type. So the reason behind using this logic data types is in order to avoid the limitations that occur in Verilog. Clear? Yes. So, and in system Verilog, while you are while you are using logic, you have to remember one thing. So logic can be used for both input output ports, but we can't use it for in-out port. Okay. So for in-out port, that means in-out port means multiple drivers are doing at the same time. That means it can be used as input port as well as output port. So while you are doing this, we can't go for logic. We should either give it as wire. Okay. Clear? So this is the system Verilog logic data type. So basically, we can say that in simple words, logic is a replacement for both wire and rich. That means when you are writing some data type as logic, then that means it could be used as both wire as well as rich data type. Yes, clear? So now, while we are seeing the example for all the data types here, okay, this is not very important like in order to see, but why I'm explaining this particular data type is in order to make you understand if what is the difference between four state variables and two state variables. Okay, for this I have taken this particular example. So if you say I have taken some various data types like bit, logic, rich, individual, every individual data type I have taken. Okay, so like again for that also I have mentioned it as some signed unsigned data type thing also. Okay, so now first I want to give the default values. I didn't assign any values. Before assigning values, I want to type some default values. So for what values I want to type the default values? For logic, okay, and then for rich, and then for bit. Okay, now if you see the output for this, okay, for logic and rich, the default is x, but for bit it is 0. Why? Because bit is a two state variable, so it can have only the default value as 0. Clear? Yes. So this is the difference. Like what will be the difference between rich and wire is that thing. Okay, so now I'm assigning some values into everything. Now when you are going to see the output here, while assigning values also, I have assigned the value for bit as 0 1 0 1 0 1 0 1 xz. But since bit can't hold x and z, if you see the output of bit, what is the output? It is 0 1 0 1 0 1 0 0. Okay, whether x or z, if you are giving in your input as x or z also, it will be converted as 0 because it could not only bit, every two state variable will be doing the same thing. Clear? Yes. So this is about the data types. Okay, and then if you see one more interesting here, like signed bit and unsigned number. Okay, this also it's not very important here. See, for positive sign, for unsigned means as you already know, it could hold only two positive values. That's why whatever number I have given, that was displayed here. But for unsigned bit, if you for signed bit, if you see here, I have given 245. But what is the value that was displayed? Minus 11. Why it is so? Because the values will be converting from minus 2 power 8 to 2 power 8. Okay, it will be calculated from 2 power minus 2 power 8 to 2 power 8. So that means it will be counting from minus 2 power 8, and that at 245 place will be for minus 11. So that is why minus 11 was displayed. Okay, clear? So this is about the various data types that you are using in your system Verilog. And one more data type that is really important and that was mostly used in system Verilog is string data type. Okay, so string data type means here in Verilog and system Verilog, until now we have seen all the data types which are like integers. That means which can type only numbers, which can calculate numbers, which can see the which can hold the number. So all this thing is bit for numbers only. But when you want to compare the values or compare the mm, characters, okay, that means when you want to write display some words or when you want to compare some words, so is there any kind of data type for this? Yes, that is called string data type. So the string data type, it is the default keyword is string here in order to declare the string data type. Okay, so Now if you see, and one more important thing about string data type is string data types can be of arbitrary length. That means you don't need to give the length at the starting itself. If you are telling the string, then the length based on the characters that you are giving, the length will be automatically incremented. So there won't be any truncation. That means after, since there is no limit, so that is why there won't be any loss of data in case of string data type. Clear? So some of the basic operations that are performed in strings, like if you have seen many kinds of operations in Verilog, is it or not? We have used various types of operators in Verilog, like comparison operators, like equality operators, concatenation, replication. Yes, is it or not? So all these operations you can do that on strings also in system Verilog. Okay, today we are going to see how are we going to do these operations on strings. Okay, so firstly, these are various kinds of operations you are going to perform in system Verilog strings. One is equality. Okay, for this the operator is, I think you already know about this. The equality operator is to equal to symbols. Not equality means not symbol with equal to. Okay, just like that you will be having many more comparison operators, like less than or equal to, greater than equal to. Concatenation, in order to combine the various variables, you will be using this concatenation operator. Okay, and then replication means in order to replicate it, that means in order to make copies of the particular variable, you will be using this replication operator. Okay, in order to know the index of the string, you will be using this indexing. And then coming to one more important thing, which is method. Okay, method in system Verilog, whatever it is, the method is nothing but we will tell it as a function. Okay, there will be some inbuilt functions in system Verilog for these strings. Okay, so whenever you want to use that function, you will be calling that method and you will be using that. Okay, we will also see what are the methods, that means what are the functions that they are already inbuilt in the system Verilog, and what are those that we are going to call and use in our strings. Okay, right? So now, as we already discussed, we will be using this equality operator, comparison operator, and all. Like, how are we going to do it? Is it or not? For numbers means there will be some greater than, there will be equal to, greater than. Okay, equality means fine. What about greater than, equal to, less than, or equal to, whatever it is? How is it going to compare the two things? Okay, so basically strings will be working on ASCII characters. Hope you all know about this. I don't need to elaborate it this much. So based on the ASCII character, the strings operations will be performed. Okay, for uppercase, the ASCII characters are from 65 to 90. For your reference, I'm just telling it. And for lowercase, it is from 97 to 122. Okay, so based on these numbers, it will be calculating or it will be performing the calculations. Yes, now let us see what are the string methods that we are using. Okay, as I already told you, string method is nothing but they are already inbuilt functions in system Verilog. What are these inbuilt functions and why do we use these functions? So whenever you are using, for example, let us take the same word as key. Okay, now when you want to know, like, how much is the length of the string that you are using, okay, how many characters does the particular string contain? Okay, in order to know the length of the string, you will be using str.len. This is the syntax, you could say. Okay, so in order to, everything should be, when you are calling a function, it should be denoted by dot. Okay, str, that means string, dot, okay, len of braces. Okay, this should for anything, not only for this strings but for any methods that you are using in your system Verilog. Remember that you should mention a dot. Clear? Yes. So str dot length. Okay, and then str dot put c. What is this for? So in order to replace some character in your string, you will be using this put c. Okay, get c. That means in order to know at for example, if I want to know at this position what is the character that my string contains. Okay, now if you see this 0 1 2 3, that means in the third position I am having a character called I. So in order to know at this particular point where the character is there, so in order to know that, you will be using get c. Okay, to lower, that means in order to convert your entire string to lowercase. Compare, in order to compare two strings, okay, whether which is higher, which is lower. Okay, you have seen all the comparison operations before itself, like greater than, less than. So all these operations will be performed here. And then substring, that means in order to take a particular part in the string, and in order to display that particular string, we'll be using the substring. Okay, so even though I understand this all about like this, but I'm still not satisfied with this. I want to explain this clearly with one example for you, at least, so that you will be remembering it forever. Okay, so let us see. So if you see my entire program, I have taken various strings. Okay, like four strings. Okay, with some values assigned to those strings. Okay, and then along with that, I have taken some more strings here, like sub, s2, lc, uc, repc. So these are four again strings, string data types, and then two are of integer data type and one is of byte data type. Okay, clear? Yes. So if you see here, all these are kinds of data types that I have used in my program. Now I am using the string methods, and I'm using it as well as I'm assigning it with to my data type variables that I have taken here. So the first thing is a dot length. So what is a? This is my a. Okay, that means I want to know the length of my A. So what is the length of my A here? 1, 2, 3, 4, 5. So the length of my A is 5. Got it? Now B dot get C of 5. What is the B here? This is my B. And I want to get the fifth character in my B. What is the fifth character? If you see 0, 1, 2, 3, 4, 5. So what is the fifth character? It is O. Yes, and then B dot to upper. That means I want to convert all the B to the uppercase. Then what happens? A L O N S O. Okay. Now I want to convert everything in my A to lower character. A E I O U. Now what I want to do? I want to substring. That means I want to have only characters from 1 to 3 in my A. So if you see, what is my A E I O U. 0, 1, 2, 3, 4. So I want to take only from 1 to 3. That means E I O. Clear? So this is substring. Okay, that means part of the string. Right? So these are all the values that will be displayed here. So I want to display all these values. Now let us see the output. See, is it the output? 5, 0, this. Is it or not? 5 O, not 0, sorry. 5 O, AL1 is O, AO. Yes, clear? So this is how. Now let us see how the operations are being performed. Now I want to, if you see this is my replication operator. Okay, you know that. If you use only single flower bracelet, then it is concatenation. If you are using double flower bracelet, then it is replication. Okay, so I'm using my replication operator. For replication operator, what I want to replicate? I want to replicate what is there in my C for 4 times. Now, what is there in my C? Hello. So, hello will be replicated for 4 times. Okay, and then concatenation. What I want to concatenate? Okay, I want to concatenate C and B. Okay, it was missed. So if you see the output, yes. So see, hello is for 4 times, and then I am concatenating hello and alone. Okay, Yes, now comes the comparison. So, for comparison, you should always remember that string is case sensitive. That means that is what I told in the starting. For uppercase, it is having some ASCII characters. For lowercase, it is having some ASCII characters. So, that is where every word is case sensitive. So, uppercase is having different values, lowercase is having different values. So, from that, B equal to D. So if you see here, B is this and D is this. Okay. For something, when you see it at the time, it is same. The spellings and all the name is same. But what is the difference here? The first one is uppercase, sorry, lowercase, and the second star A is uppercase. So that is why these are not same. See, not same. Okay. And when you see the when you see the second one, like B equal to B. Okay, for this B equal to B, if you see what is B here, again I am just equating both. So since B is equal to B, so that is why they are same. Okay, and the third thing is B is greater than D. For B is greater than D, since B is not greater than D, like B is greater than D, so that is why Alonso is greater than Alonso. Okay, because this is having some values and this is having some other values. So that is why based on the ASCII character values, the greater than or less than comparison is done. Clear? So this is about the data types. Some of the data types, not all data types. We will discuss some more data types in the upcoming sessions. Okay. So as for now, these are the data types that you will be seeing in system Verilog. Hope you are clear about these data types. If you are still having any doubts, you can comment me in the ping box or in any of my social media handles that I have given in my particular channel. You can go check it out there, and also follow me on LinkedIn and Telegram channel, where I'll be uploading the ppts of this presentation.